Hello everyone, welcome to the virtual workshops. I'm Jayanti Rajaraman. I'm a customer delivery architect at AWS. My specialization is around mainframe migrations and modernizations. In this episode, we are going to see how to seamlessly convert the COBOL applications to Java Spring Boot and run it on AWS. I will guide you through a demonstration of automated conversion using one of our partner tools called Blue Age. So before I get into the demonstration, I just want to provide a brief overview of what automated code refactoring is. So as you all are probably aware of, there are many different patterns to modernize and migrate workloads from mainframe to the cloud. And each pattern offers its own unique benefits, and each pattern is chosen based on the workload, the desired end state, and the migration time that you have. So these are all things to consider when determining the best pattern to use. In today's session, we are focusing on the legacy automated refactoring pattern. So what is this pattern? In this pattern, the code, the data, and any associated dependencies are automatically converted to a modern language, a data store, and a modern framework as well. With this pattern, you're guaranteed functional equivalence as compared to what you have on mainframe today. So in here, what you see is that anything in blue, so the mainframe to the new platform, anything that you see here in blue stays the same. So what you see here is that the business functions that exist on mainframe stays exactly the same. What has changed is everything that you see here in yellow. So your entire software stack has changed to a modern technology stack. So whether it's your operating systems, your databases and files, any application middlewares, the code, as well as utilities that may exist on mainframe, and your actual data itself. So all of this has been transformed into a modern technology with this particular pattern. So what really is involved in a mainframe automated code refactoring project? So this project involves the conversion of code, dependencies, and data, as I previously stated. So for example, you can see here on mainframe, you may have your code in COBOL, PL1, assembler, JCL, and so on. So this code can be automatically converted to a Java or a .NET, for example. And so the automatic conversion automatically generates the modern code as well as any associated data access layers, any data format changes, and dependencies all together with minimal manual intervention. So the way it's done is it uses certain patterns and rules to transform the mainframe screens and the indexed files, as well as any batch stacks to a modern target stack. So as I stated, this kind of transformation gives you guaranteed functional equivalence, and the result is an object-oriented and a service-oriented modern application. Now, given that this process is mostly automated, it is also very quick and it greatly reduces the risk from a mainframe migration standpoint. So how does this process work? This process has two steps. So the first step involved is the reverse engineering. So what happens in the reverse engineering is that the code and any other associated elements that are required from mainframe is ingested into the analyzer tool. And this tool analyzes the application modules and it will generate several outputs. The outputs basically will consist of an application model which shows your program and the data dependencies as well. So what this output helps with is to come up with a detailed strategy with the different components, data mapping, conversion rules, and ways to decompose your work packages as well. So once you've reviewed this output and decided how you want to break your monolith into macro services and decompose them, the analyzer tool generates an intermediary module, which can be proprietary to the tool that's being used. And that becomes the input into the next part of the process. So the next part of the process uses the output from the analyzer and automatically generates code in a technology of your choice. So you could, for example, take a COBOL code and automatically convert it to a Java Spring Boot application, as I'm about to show you, and deploy it on Amazon EC2 for compute and the Amazon Aurora database for the data storage. So this is a completely from an architecture standpoint, it's an elastic web architecture, and this is one of the typical deployments. However, I do want to point out that the target technology stack can be customizable. So for example, you can use Amazon SQS for messaging. You can use Amazon Elastic Cache for in-memory shared data structures. You can use ECS or EKS for containers, or you can even deploy using AWS serverless Lambda functions. Another thing also is that this generates a service enabled stack that allows you to expose your services via the API gateway. So as you can see here, the automated code refactoring is a fast and coherent transformation of your complete application that currently exists on mainframe. So before I actually start the lab where I'll show you how this conversion happens, I want to review the process so you can follow along as I get into the lab. So the first thing that I will be sharing with you and showing is the mainframe application that's going to be converted. So I'll actually pull up a mainframe terminal and show you the CICS application as it exists on mainframe, so that when you review it while it's executing on AWS, you can see that it's exactly functionally equivalent. And then the next step of that would be to take the inventory from mainframe and import it into the analyzer tool. And here I will show you the output, some of the outputs from the analyzer tool. And after we have done the analysis part, we will get the intermediary modules, which is proprietary to this Blue Age tool, which will be imported into the third step, which is called a Blue Age Velocity tool. The Blue Age Velocity tool uses the intermediary module to actually transform the code and generate a Java Spring Boot application. And as part of this, we are also going to convert the data from VSAM into a Aurora Postgres database. So I will show you how we are going to take the data and migrate the data into the Aurora Postgres database as well. And all of this application will be deployed on a Tomcat server on EC2. And finally, I will show you a quick test of the application when it's executing on AWS. So as you can see, the source environment I'm using for this particular demo is COBOL. We have some JCLs that I use to load the VSAM files currently on mainframe. So the COBOL becomes Java Spring Boot applications. The JCL will be converted to Groovy. The BMS maps are converted to AngularJS, and the VSAM files are converted to a Aurora PostgreSQL database. And the application itself, we call it a Murac application. It consists of 4 CICS screens, transactions. There's a menu, inquiry, maintenance, and order entry. And then as far as the components of this application goes, we have BMS maps. We have the COBOL programs associated with these transactions. We have batch programs that are currently used in mainframe to load the VSAM files. And then we have the VSAM data sets themselves, which are part of this application. So this consists the inventory that's going to be part of this demo. All right, so having said that, I'm now going to move into the demo part of it itself. So the first part of the demo is showing you the application on mainframe. So I'm going to pull up the mainframe application in just a minute. Okay, so this is the mainframe application. So I'm just going to log on to the mainframe CICS region so you can see the application. So this application consists of a menu transaction from where you can view the customer information. can maintain customer details as well as do order entry. So for example, I'm able to pull up the customer information here. If I choose to, I can add a new customer, or I can even change the details of this particular customer that I just pulled up. So this is the mainframe application that I'm going to be using in my demo. So now I'm going to shut down this connection and show you the actual conversion itself. So I'm going to let me disconnect my mainframe session here. All right, so as part of this demo, what I have done in preparation for the demo is I went ahead and set up my an EC2 instance, and in that EC2 instance, I've already installed the tools required for the demo, which would be the Blue Age Analyzer, the Blue Age Velocity tool, and I've also installed my Tomcat server in this thing in my EC2 instance. So what you see here is my EC2 instance where I've installed the necessary tools. So the first thing I would like to show you here is that I have, as a preparation, I also went ahead and downloaded the modules from the application that I just shared with you. So you can see here that I have my maps, my CICS definitions, COBOL programs, copybooks, JCLs, and as well as the VSAM definitions for the files that are required. So these are all the elements that I'm going to import into the analyzer tool, and I got all of these from the mainframe. So the first step is the analyzer part. So I'm pulling my Blue Age Analyzer tool, and it might take just a small second for this to come up. So this is an Eclipse-based tool. So if you're familiar with Eclipse-based tool, it's very easy to use. So this is my analyzer. So I'm going to go ahead and import my assets, which is all the stuff that I just showed you that I have downloaded from mainframe. And I have it over here. So I can call this project anything. I'm just calling this Murac Reverse because my application is a Murac application. So it helps me remember that. And what I'm going to do here is I'm just going to point to the folder where all the necessary elements exist and import it into the tool. So that's the Murac code. So I'm going to import all of those elements into the analyzer tool. Okay, and so what this tool does is the results of the analysis is stored in an internal graph database. So what I'm doing here is I'm just creating a graph database where it can store the analysis results. So once I have given it a database name, I'm just going to go ahead and let it finish. So you can see that here it's analyzing the source code and importing all of the elements. We'll just give it a few seconds to finish. So you can see that it has completely imported all the elements. So if I click on the assets here, you can see it has imported the code that I just showed you, the BMS, copybooks, JCLs, and so on. So this is the code that it has analyzed. So one of the things that's critical to the analysis process in a mainframe modernization and migration is understanding the existing dependencies between the programs and the data so that you can decide how to decompose the modules. So the tool itself automatically comes with certain graphs built into it, which gives you a very good visual of the dependencies. So right here, all I'm doing is I just want to make sure the graphs display properly. So I'm just kind of doing some preferences to make sure that displays correctly on my screen. And then what I'm going to do is let me, for example, pull you the intermodule graph. So I'm going to use a view that I've found to be most useful, which is called the smart organic view. So you can see here, this clearly gives you a visual of all the dependencies that exist between the programs and the tran IDs. So this helps you decompose the module. So in my case, this is a small application for the purpose of the demo. So I'm going to essentially convert all of this and deploy it together. But if you were doing this for your real mainframe applications, it's probably going to be bigger applications. And this gives you a visual to decide how you want to decompose it. And then based on the dependencies that that exist, you will have to decide on the integrations and how you're going to keep the data in sync and so on. So this visual is really helpful from that aspect. Another thing you can see here is that it has highlighted any missing elements. So in any real mainframe effort, there is no way you at the very first attempt you know every element that you need for your application. So you don't have to worry about it. The tool is going to tell you and guide you along on any missing elements. So here you see that it is missing an element, and I will go ahead and import it at some point. So this is one of the dependencies that it displays. It can also display, any data dependencies as well. So again, these are all graphs that it automatically generates that gives you a great visual into this. So from a data dependency standpoint, again, you can see that all these red elements here are the data dependencies. So you can see that, for example, the customer master file, all these other programs are dependent on it. You can see that the product file is only the order entry system is dependent on it. So again, this visual is very critical to helping you decompose your workloads when you decide how you're going to migrate them. So the other great thing is this is a visual into it, but there's also many gremlin queries that you can use if you rather want to use queries than visuals to understand what's missing and so on. So the tool itself comes with several queries built into it. So you can just run those queries as well if you choose to. So I'll run the query once it loads. So what I'm going to do in the meanwhile is, obviously there is a missing element that is required before I can proceed further. So I'm going to go ahead and import the missing element. Again, you don't need to import everything. You can do incremental imports as you progress along and find other elements that needs to come in. So all I'm doing is say incremental imports. So at this point, you would have gone ahead and found out what the element is and got it from mainframe and saved it into your workspace as well. So that's exactly what I'm doing here. So I have a folder called missing where I have my saved element. So I'm just telling the tool to go ahead and import this thing. So again, it's going to go ahead and analyze it and include it. So now if you see here, if I go back to this intermodule graph that I was sharing earlier, you can see this is no longer highlighted in red, right? So it means that it has successfully imported that module. A couple of other things that is really useful information. Like you can see, it has gremlin queries that you can run as well. But another important thing I wanted to show you is metrics. So you can go ahead and compute the metrics for the applications that you've imported. And this is going to provide you useful information, again, which helps you decide, how complex is this migration going to be and how are you going to approach it. So you can see that for each of the modules, it shows you the lines of code. It can tell you how many lines of code is commented and not commented. It gives you complexity view, the cyclosomatic complexity, essential complexity, and so on. So based on this, you'll know how complex your workload is, how big your workload is, and so on as well. So these are a couple of useful metrics and tools that is generated as part of the analysis. So in the real world, once you have all of this generated and you've decided which parts of the component you want to modernize, you can tag them. Again, like I said, for the purpose of this demo, I'm just going to use all of the elements. But if you wanted to only pick certain elements, you will be able to just go into the intergraph module, which I shared earlier, and simply select the elements that you want and tag it and only export them and modernize those workloads. So now that we've done this, one of the other things this module does is that intermediary module that is generated, right? So the analyzer has already generated that information. So I'm going to go ahead and export it so I can use it in the next part of my project. So to do that, all I have to do is export assets, and I'm going to ask it to export the DSLs that have been generated. You can save all this on Git repositories if you want to, but in my case, I'm just saving it on my local drive. And you can see that it is saving all of this into this folder that's highlighted over here. So I'm going to go ahead and ask it to continue, and it has successfully exported all the modules. So this would be the end of the analyzer part. So I'm going to go ahead and close the analyzer. So what I want to show you before I get to the next part of it is you can see here that in the analyzer part, this is just this is the intermediary module that I just showed you. So it has gone ahead and created all the COBOL, JCL programs and so on in a format that's proprietary to this tool. So what I'm going to do, the next step of this process is the actual conversion of the code. So far what we've done is imported the modules and then analyzed them, decided how we are going to decompose it, and gone ahead and generated that intermediary module. So in this step is where you're actually going to convert the code into a Java Spring Boot application. And for this, I'm using a tool called Blue Age Velocity tool. Now, this tool is capable of doing other than Java Spring Boot applications. It's not just restricted to that, but in this case, that's what the target stack is going to be. So in this tool, what I'll be doing is I'll be importing that intermediary module that we just generated. So I'll just give this a second to launch. So while I'm waiting for it to launch, I also want to go ahead and show you that one of the other things that I did get from mainframe from a data standpoint is that I have also gone ahead and downloaded all the data required for the 4 VSAM files that we will be using. So I'll be using this data and for the data migration part of it. All right, so this tool again is an Eclipse-based tool. So the same thing, it's a very, if you're used to Eclipse, it's a very easy to use interface. Okay, so there are a couple of things that need to happen in this tool. First is actually importing the intermediary modules. The other part of it that we need to do in this tool is also set up the configuration and the rules on what the target stack is so it can convert the code accordingly. So first, I'm going to just go ahead and import the intermediary modules that I just generated from my analysis. So this is what I'm doing. I'm going to ask it to import the two modules that I just showed you. So those modules exist in my local libraries. So I'm going to go in here. So the output from the analyzer is in this folder. All I have to do is just select it, copy the project into the workspace and finish. So at this point, it has imported all the required information in terms of your source code and JCLs and so on. So you can see that it has all that information in here. So next, what I need to do is I need to set up the Blue Age Velocity project so that it's configured to convert my code into this Java Spring Boot application. So in order to do that, I'm going to create a project. I'm going to call it Murak Forward. Again, my application is called Murak, so I'm just calling it the forward part of it. And all I'm doing here is setting some parameters that's going to help this thing, the tool, know how to generate the source code, the target code. I mean, so I'm going to, since this is a CICS application, I'm going to use enable jigs, which is the the Blue Age equivalent of your CICS. And then since it's mainframe application, I want to make sure I set up my encoding, in this case, the EBCDIC encoding. And then I also am going to set up here to use, because I'm converting to a Spring Boot application, I just want to make sure I give it a Spring profile, which I'm calling Murak. And In this case, I'm going to be deploying my application and running it as a local host. But you would configure this in the real world to be whatever in domain name that you want it to be, and so on. So in this case, I'm just going to leave it as local host. And at the end of it, I just say finish. And at this point, the forward project is ready. So now the next step is to actually ask this tool to go ahead and do the code conversion. So to do that, I just go in here and I say I want to modernize from my analyzer DSLs that I've just imported. And when I do that, it's going to ask me for some license information. And then I'm just asking it to use the configurations and rules that I set up in this Murak forward project. And I'm also giving it the name of the root package, which is again, this is all relative to the tool that I'm using. So once I've done that, I say okay. And you will see that it has started converting my code here. This shouldn't take too long. It should be done here in just a bit. So while that's happening, okay, so what I want to show you here is, there you go. The code, it has been converted. You can see that it's been successfully generated. So what you see here is that you've seen several folders have been created. So it has created a POM, which is basically going to be the packaging part of it. But what you see here is that it has created this folder called service. So the service this contains, the service package contains the service layer for the Spring Boot Java backend application. Then you see that there's a web folder. The web folder is going to actually have your front end application. This is your Angular JS application, as you can see here. And then the tools, there is a folder here that's also called tools. So there's a service web, and then there's a tools folder. So the tools folder contains all the utilities for the tasks, such as the file access and so on. And then of course you have a POM folder. The POM folders contains all the information required to link and generate a deployable WAR file later on. So now that this has happened, the next thing I want to show you is, so in a CICS application, you have a lot of definitions that happens on the mainframe, like the PPT, the PCT, and the FCT, and so on. So what we are going to do now is that we are going to create a schema for the JIX, which is a CICS equivalent. We are going to create a JIX schema, and the JIX schema is going to be loaded in the Aurora database. So one of the things that I have gone ahead and done is gone ahead and created an Aurora database here that we can use for our project. So you can see that it's a Murak database is the name of the database. Uh, and so I'm going to be using this database and this writer instance to configure my Tomcat application, as well as to load the CICS definitions. And later on, I'll also be creating different schemas for the VSAM files as well. And in the case of the demo, I'm loading all of this into the same database, but in the real world, you can have your KICS definitions and your actual data files in separate databases as well. So this is the database that I have here. And so I'm going to access this database using pgadmin tool. So back here, I have connected to my Murak database. So just logging in so I can connect successfully. There you go. So that's my Murak database that I'm going to be using. So you can see here right now, if I go in here and if I go into the tables, I don't have any of the definitions and so on over here. So what I'm going to be doing is I'll start with this clean project. So let me delete all of the objects I have here. So once the way to load these tables is, we have also gone ahead and from the mainframe, we have created a SQL for each of the tables that's required. So if you see here for the FCT, PPT, PCT, there is a corresponding SQL that that we have created that's going to create the corresponding tables. So all I'm going to do is execute this SQL. So we can create the corresponding schema files in the pgadmin tool. And so this is all again going to reside in the Migrate database. So I go to my Migrate database. I'm going to go to my query tool and execute this query. Again, you can see it has successfully created the schemas. So again, all I have done at this point is only create the schemas, right? So I have a schema corresponding to an FCT, a PPT, a PCT, and so on. But I have not actually added the definitions for my Murak applications, VSAM files, or programs or transactions into this table yet. So what I need to do for that is execute a query. So again, going back to one of the other things that I got from mainframe, from my CSD list from mainframe, is all the information that I need for these definitions as well. So I'm going to execute that query here in the pgadmin tool. And so this query, what it's going to do is, again, it's going to, in the Murak database, that it's going to insert the definition data into the schema tables that we just created. So let me go ahead and execute that. So here you can see that it has successfully inserted the data for the definitions into the table for the Murak application in particular. So that's, we have taken care of the CICS infrastructure and making sure we have copied all the definitions into the JIX application. So now, going back to the Blue Age Velocity tool, what we are going to do is we're going to create the deployables that we need. So we're going to create the WAR files that we need to deploy into the Tomcat application. So let me just quickly go in here and make sure I have my JDK. So at this point, all I'm trying to do is I'm just going to use Maven and go ahead and create the WAR files. So now that I've set up my JDK over here, I just come in here to my POM. I'm going to go ahead and ask it to do a Maven install. So again, it's going to be generating my WAR files for me. So while it's doing this, let me go back here. So far we have not done any data migration activities. So in order to do the data migration activities, I am going to use another tool that is called, that's another Blue Age tool. So I'm getting into the Blue Age administration control. So here I have my Tomcat application manager. I have this Blue Age tool installed here already. I have not yet deployed my applications, but I'm going to go to this tool. So this is a tool that's going to help me actually migrate my data. So logging into this tool. All right. All right. So to deploy the data is fairly easy. So I'm just going to use the listcat definitions from mainframe to actually load this data. So I have all of the listcat that was generated. And I'm going to ask it to use that. So you can see that there's these 4 VSAM files that we have. So I'm creating the schema that's corresponding to each of these VSAM files right now. So you can see that these are the 4 files. It has a record length, and these are fixed record files. So at this point, we've created the corresponding schema. I have not yet loaded the data. So in order to load the data again, this tool is fairly simple to use. You just click roll data, and you simply point it to the file where you have the data. So again, One of the things I showed you initially was that I already had the VSAM data downloaded from mainframe. So I'm just going to use the data here and load it onto my BlueSAM server. So you can see that it has loaded 20 records. I'm going to quickly repeat this procedure for the other 3 files as well. So the next file is the invoice control. So same thing, just takes a few seconds, and of course, this is a fairly small file at this point, but so you can see that the process to do it is pretty simple. And then the last file here is the product file. So the product file is 16 in length, and I just pointed to the product file here. Click on open, load on server, load on BlueSAM. All right, so now you can see that all of these files and the data records have been loaded into my BlueSAM. So the data migration has been successfully done. So if I go back to my Blue Edge here, you can see that it has successfully generated my files for deployment as well. And I'll quickly show you these files here. So basically what we've done is we've generated 2 files. I'm done with my code conversion and creating the deployment files. So the files I've generated are 2 WAR files. One is for the web front end and one is for the back end. So these files are here in the service. So this service one would be the backend file. So if I get in here, I can see that it has generated a forward service war. And similarly for the web, it has generated a forward web war. So now that the files have been generated, I'm going to go ahead and deploy these files into my Tomcat server. Here is my Tomcat application. So I'm going to just log in here and deploy my files that I just created. So let me make sure I get my file names so I can deploy it. So here is my file for the forward web. And then the war file for my backend is located in the service target. So again, I'm just going to copy this so I have this. All right, so I'm going to go back into my Tomcat server here and finish this deployment. First, I'll just deploy the forward one. Okay, this is my forward web. Let me make sure the deployment finishes. Just give it a second. Okay, so the forward has been deployed. Now I just need to repeat this for the backend war as well. So it would. So I'm going to take this war file. Right. So you can deploy this, from your Eclipse as well. I just wanted to show you the deployment here, but so this is the backend deployment that I'm doing. So I've deployed the service. So again, let's make sure it deploys. Just give it a second. So just to recap what we have done so far is that I showed you how we took the application from mainframe and imported into the analyzer tool. We saw the outputs from the analyzer tool. Then we took the output from the analyzer, you imported it into the velocity tool, and then from there we had it convert the code to Java Spring Boot application, and we created the war files and we've deployed it into the Tomcat server. We've also taken all the definitions from the CICS on mainframe and converted it into schemas and added those definitions into the Postgres database. We also took the 4 VSAM files, used the Blue SAM tool and loaded all of that, generated the schema for those VSAM files, and then loaded the data for those VSAM files as well. So now we have completed all the steps in this process. One other quick thing I want to point out is that I've also configured the Tomcat server itself so that it's pointing to my Aurora database. I could probably just quickly show you that. So I just basically am pointing here. You can see that I've updated the resource type here to point to my database endpoint. So the Aurora server is configured to connect to the database. And then, oops, let me go back here. So now that I have, you can see that I have my forward and the forward service deployed. It's both running. And the other thing I wanted to also point out is there is a couple of other applications that you see here. So you have a gap walk application. So this is a Blue Edge application that kind of connects the front end web server and the back end service. So that has also been already deployed. So now I think we are ready to test the application. So to do that, my application in this case, I'm just running it as a local host. So you can see that I'm in the JIX application. So this is again the equivalent of the CICS on mainframe. And I can enter my TRAN ID just like I would do in CICS. And you see the application displayed here. It looks just like it did on mainframe. When we started off and we looked at the application on mainframe, it looks exactly the same. I mean, there are a few customization options here in terms of how the screen would look in terms of the background and color. But other than that, the application looks exactly like it is on mainframe. So you can, I can just quickly test it as well. All right. So I can display the customer information. And this is exactly what I was doing on mainframe as well. You can see that it pulls up the customer information. I can go ahead and maintain a customer or update it. So if I want to just update the information, I can go ahead and change this customer. And so you can see the messages, everything works just like it did on mainframe with the same TRAN IDs and the same interface and the same look. So there you have the CICS application has been deployed on mainframe, and you can see that it works just like it did on mainframe. So so with this, what you've seen here is that it's completely possible for you to refactor a mainframe application and deploy it to run on AWS using AWS services, including, in this case, it was an EC2 Tomcat server, but you can certainly deploy it on other tech stacks as well. So with that, I think I'm towards the end of my demo. All right. So what I want to leave you with is that there has never been a better time than now to modernize your mainframes to run on cloud. And there are plenty of resources even on our AWS website. So, there is case studies and blogs that can help you guide along. And our team is here to help you guide along in this journey as well. So looking forward to helping anyone who is interested in migrating their mainframe workloads to cloud. Please do reach out to us so that we can help you assist in this journey. Thank you.